Section 3.3 continued. Now we're going to use the slope formula to compute the slope of a line given two ordered pairs that satisfy the line. So here's our slope formula just to remind you. And our first set of ordered pairs that we're going to find the slope for the line that goes through these ordered pairs is 0, 5 and -1, -5. So the first thing I'm going to show you here is that we can have this one is x1 and this one is our y1 and this is our x2 and this one is our y2. Now those are quite arbitrarily named as x1 and y1 and x2 and y2. It really doesn't matter which one's which. So the formula says I'm going to take the y2 and I'm going to put it in first, and then from that I'm going to subtract the y1 and then over, and then I'm going to put in the x2, and that one is a -1, and then subtract the x1, which is 0. And then I'm going to simplify that using order of operations. This says -1 plus a -5, which gives me a -10. And then that's over -1 minus 0, which is a -1. And then I'm going to simplify that. Now when I write slopes, I'm either going to leave them as reduced fractions or I'm going to write them as whole numbers. A negative divided by a negative needs to be simplified to a positive, and 10 divided by 1 is 10. So I will just simply write that as 10. So the slope of this line is 10. Now I want to show you something because I think it's important that you see this at least one time. Now it wouldn't have mattered if I had chosen this one as x1 and y1, or if I had chosen this one as x2 and y2 and this one as x1 and y1. So let's watch what happens when I do it that way. So this is now my y2, so I'm going to write it first and then subtract, and now I'm going to put some parentheses because my y1 this time is a negative number. So I'm going to put in the -5, and then I'm going to go for my x2, which is 0, and then subtract, and then what my x1 is, which is a -1 here, and I should have some parentheses around that one so it doesn't get confusing. And now I'll simplify again. So this says 5 subtract a -5, which is 5 plus 5, which is +10. And then this is over 0, subtract a -1, which is 0 plus +1, which is a +1. And then we'll simplify that, 10 divided by 1, which is 10. And you see, no matter which way I computed it, that my slope was exactly the same. It was this 10. So the subscripts just help me keep track of the fact that this number here and this number here form an unordered pair, and this number here and this number here form an ordered pair. See, ordered pair there, ordered pair there, and that's all those subscripts are doing for me. So let's do that one more time with our second example here. Maybe you want to pause this and you want to try it on your own and then come back and check and see if you got the right answer. So if you want to do that, pause right now. Alright, so the slope here, m, is equal to, and then I can call this x1 and this one y1, and then this one x2 and this one y2, and then I can say, okay, -1, subtract, and then I put in my y1 here, and my y1 is a +1, over my x2, which is 1, subtract, and then I put in my x1, which is a -1, and so now I have -1 plus a -1, which is a -2, over 1 minus, or subtract a -1, which is 1 plus 1, which is +2. And so now I have a -2 over a +2, which simplifies down to a -1. And so now the slope is a -1. And you'll notice that if you compute it the other way, you've got exactly the same number. But what you'll notice is that in your numerator, you would have gotten a positive, and in your denominator, you would have gotten a negative. So you would have gotten a slope of 2 over -2 if you would have computed it the other way. But you see, it's still equal to a -1. All right, now we'll continue our next examples in the next lecture, and then I may do another couple just for you to try on your own. All right, we'll see you soon.